So, just gonna start off. This is lesson 10. Honestly, it's a very, very quick lesson. I think we'll be here less than 20 minutes. Basically, all it is going over ANOVA. So, with that, kind of like what is ANOVA? It's basically just a way to compare the means of more than two independent groups. This is kind of like a loaded sentence. Just know that it's like take away from this that it's means and more than two. Because a general question that they like to ask is, you know, when should you use ANOVA, or is it appropriate to use ANOVA, stuff like that. And so just know if it has to do with means and more than two independent groups, generally yes. But another question you might ask is, why would we use it? So there are two real reasons. The first one is that the chance of a type 1 error kind of goes up if you're doing multiple individual tests. So type 1 error occurring basically means that we have a greater instance of finding some kind of significant result when there really isn't one, just because of us doing the multiple tests each individually. It kind of like increases that risk, and with that, the overall alpha level ends up being higher than 0.05. So it kind of like skews what we could consider actually being evidence, what we consider being significant, stuff like that. So that's why I use ANOVA, because it doesn't skew the alpha level. It doesn't increase the odds of a type 1 error. It's just a safer, easier method. So really what it uses is the F distribution. So you just have to compute the F test statistic to determine a p-value. The F distribution has 2 degrees of freedom. So you've got 1, which is between groups. That's the numerator. It's degrees of freedom equals k minus 1, where k is the number of groups. And then you've got within groups, which is the denominator, and that's n minus 1, where n is the total sample size with all groups combined, and k is still the number of groups. So then hypothesis testing with ANOVA, basically the assumptions for being able to use ANOVA is that the samples are all independent, the response variable is either normally distributed, or the sample sizes have at least 30 in them. So the population variance is equal across all responses of group levels. So basically what that means is that the largest standard deviation divided by the smallest sample standard deviation is not going to be greater than 2. That's basically all it's saying. It's kind of a lot for something as simple as that, but that's basically all it's saying. Then the null hypothesis is always going to be that the means are equal to each other, and the alternative are always going to say that not all the means are equal to each other. So with that, to calculate the test statistic, really it's all going to be using some kind of software. I know you guys are probably going to be using Minitab. I would go through something with you, but again, I kind of said it before, but like every single little Minitab is different. So I could tell you guys to do one thing, and since I'm on a PC, if you were on a Mac or something, then it might be a different button, or it might be in a different location, and so that would just like lead to an increase in confusion. So I'm just sticking to testable stuff, like how they'd actually test you. So when you like see the test statistic in Minitab, it's going to provide you with 3 different degrees of freedom. So there's going to be the between, the within, and it's also going to give you the total, but you only need 2. You only really need the between and the within, but if they give you the total, you could technically calculate the other one. So you just have that. Then you just have to turn the p-value, make a decision. Just one question that I've been asked before is that is 0.05 still kind of like the standard for whether we should accept or reject? And yes, it is. You should honestly, like, if you want, get that tattooed, get that engraved. I don't care. Just like always remember 0.05. And then you're just going to state a real world conclusion. Exact same thing we're doing, like we have been doing for so long now, just, a little bit different because we're using ANOVA. And yeah. that's honestly it, guys. That is the entire lesson. So with that, we're going to go right into the review questions. So which of the following choices describes a problem where using ANOVA would be appropriate? I'll give you guys a minute to read all the options and then make your selection. All right. Yep. Seems like you guys are getting this one. So you're right. It is D. So the reason why it is correct is because it's comparing the means and is using three different groups, which is more than two. The reason why A is incorrect is because it's proportion, and B and C both aren't really. B only uses two, and C is more of a correlation. So it's not really just asking about comparing means. All right, so review number two. Researcher wants to compare the mean incomes of individuals who attend four different types of high schools. They aren't sure if they should conduct multiple independent t-tests or if they should do a one-way ANOVA. Which of the following is true? So I'll give you guys a minute to read over this. All right, yeah, you guys are quick tonight. Yep, you're right. Let's see. Should perform one-way ANOVA to avoid having inflated alpha level. All right, so this is taken right from an online source. It would be like what you get on exam or something, where you just get this little snippet, and it's basically just asking you to analyze it. So from this graph, it's saying that your P level is 0.026. So then it asks you the questions down here of based on the alpha level, we should do what to the null hypothesis, which state, oh, it's asking, is there not enough, is sufficient evidence to state that the median house prices are not equal? Then it also asks, houses tend to be most expensive in which state, and house prices tend to be most variable in which state. So I'll give you guys a little bit to go over this. I know we didn't really talk about those last two bits, but I'll go over that as well. Just give you guys a minute to like answer it. All right, yeah, looks like you guys are getting it. So because 0.026 is less than 0.05, you can reject the null because there is sufficient evidence. And so to answer these next two, you just have to look up at the table up here. So the first one, asking most expensive, that's just asking which one has the highest mean, which is California over here with a 715. And then which house price is the most variable, that's asking for standard deviation, which is also California because it's got a massive standard deviation, which, I mean, that kind of says that they might be giving away free houses in California, but whatever. I didn't write the question. So, yep, that's just all written out. And so, yeah, no, that's it. That's all of lesson 10. Hope you learned something or enjoyed the review. I'll be doing the exact same thing on Sunday. And so next week, I will say we'll be doing a huge midterm review. Should be going over everything that might be on the midterm. So be sure to tune in for that and have a good night. I hope, I hope everyone's Halloween went well. I was studying sometimes. So yeah, have a good one.